Okay, class, we're starting in section 5.5, fractions, decimals, and order of operations. Now we have section A, converting between fractions and decimals. Now, it says here, to write a decimal as a fraction, put the digits without the decimal point in the numerator, and use the place value of the last digit to determine the denominator. To write a fraction as a decimal, divide the numerator by the denominator. Now, we have a few examples here. It says example, complete the following chart. Express all fractions in lowest terms and give exact decimal values. Do not round. So, your decimal value here is blank and your thought process is blank. So what we have to do here, we have to take this fraction and we will set it up to be divided. We'll take 4 into 3 and put a decimal and add 2 zeros here. Now when we add these zeros, it doesn't matter how many zeros you add. You can start off with 1 or you can start off with 3 or 4 or 5. But just start off with a couple. I would say I like to start off with 2. That because a lot of times you will end up with at least 2 or more digits behind the decimal. So we have 4 and a 3, which is 0. We bring up our decimal. 4 goes into 30 7 times. 7 times 4 is 28. And 30 minus 28 is 2. We bring down our 0. 4 goes into 20 5 times. 5 times 4 is 20. 20 minus 20 is 0. So our answer here is 0.75. And so we will write 0.75 here under the decimal. Now, let me state this. I didn't state this before, but your thought process is actually the way how you did the problem. Okay, now we have our decimal here. We have 0.85. We write that as a fraction as we do our thought process. Now, we know it's going to be 85, but we look at the last place value of the decimal, which is hundredths. So it'll be 85 over 100. Now we have to do the prime factorization of 85 and 100. Now I did this off to the side. The prime factorization of 85 is 5 times 17. And the prime factorization of 100 is 2 times 5 times 2 times 5. So we replace them. In our numerator, 85 becomes 5 times 17. And our denominator, 100, becomes 2 times 2 times 5 times 5. Now, these 5's here simplify out. And you're left with 17 in your numerator and 20 in your denominator. So your fraction would be 17 over 20. Now, we scroll down here. I'm going to go through a couple more examples here. What I'm going to do is this here. You could copy this down at your leisure. But I'm going to go down here to this example. And actually these these 2 examples here. Well, I guess the last 3. Okay, so we have here 5, 6. Okay, now we take 6 and the 5 here, put a decimal, put 3 zeros here. 6 goes into 5 0 times, but 6 goes into 50 8 times. And don't forget to bring up your decimal. 8 times 6 is 48. 50 minus 48 is 2. You bring down your 0. Now we say 6 goes into 20 3 times. 3 times 6 is 18. 20 minus 18 is 2. So we bring this 0 down. We say 6 goes into 20 3 times. 3 times 6 is 18. 20 minus 18 is 2. And you know we're going to keep repeating this. So our final answer here is, now this means approximation when the equal signs are kind of squiggly a little bit. That means approximation. So it's 0.83 with the repeating decimal for 3. So it'd be 0.83 with the repeating decimal bar. Now, we look here. We have negative 3.6. Okay, the first thing we need to do is this here. Since we want to change this decimal to a fraction, we keep the negative 3 out front, and this 6 becomes 6 tenths, because this 6 is in the tenths place. Now, we take the prime factorization of 6 and 10. So first we carry over the negative 3. The prime factorization of 6 is 2 times 3. The prime factorization of 10 is 2 times 5. These two simplify out. And then your final answer is a negative 3 3/5, which we have here. Now, we have 5 3/8 that we want to change to be a decimal. Now, what we can do with this 5 3/8 is make this into an improper fraction. 5 times 8 is 40, plus 3 gave us 43 over 8. Now we would take 8 into 43. 8 goes into 43 5 times. 5 times 8 is 40. 43 minus 40 is 3. Now you see I had this decimal in 3 zeros. So we'll bring up our decimal and we'll bring down this 0. 8 goes into 30 3 times. 3 times 8 is 24. 30 minus 24 is 6. You bring down this 0. 8 goes into 60 7 times. 7 times 8 is 56. And 60 minus 56 is 4. You bring down your 0. 8 goes into 40 5 times. 5 times 8 is 40. And 40 minus 40 is 0. So our answer here is 5.375. Now, we scroll down here. We have another example. We have convert 28 over 13 to a decimal rounded to the nearest thousandths. Now, we would take 13 into 28, but since we're asked to round to the nearest thousandths, that means that we need to go to the 10,000ths place and see whether that number will have us to round up the thousandths place or leave it the same. So 13 goes into 28 twice. 28 minus 26 is 2. We bring down our 0. Don't forget to bring up that decimal. 13 goes into 21 times. 1 times 13 is 13. 20 minus 13 is 7. We bring down our 0. 13 goes into 70 5 times. 5 times 13 is 65. 70 minus 65 is 5. You bring down your 0. 13 goes into 50 3 times. 3 times 13 is 39. 50 minus 39 is 11. We bring down our 0. 13 goes into 110 8 times. 8 times 13 is 104. 110 minus 104 is 6. We can stop here. Now we want to round to the nearest thousandths place. We look at the 10,000ths place. This 8 falls in between 5 to 9, so we will add 1 to this 3. So it'll be approximation 2.154. And that is the final answer for that problem. Now we go to section B, comparing decimals and fractions. It is usually easier to convert the fraction to a decimal first and then compare. Okay, examples. Insert less than, greater than, or equal to form a true statement. Now, number 1, it says 1/2 and 0.54. Now, typically, I find it a little easier to change the decimal to a fraction because of the process I showed you all before in the previous chapter. So 0.54 is actually 54 over 100. Now we could cross multiply. We would do 1 times 100, that would give us the first amount, and 2 times 54, which will give us the second amount. 1 times 100 is 100, 2 times 54 is 108. We know 108 is greater than 100, so we'll have our inequality pointing to the 1/2. And that's our final answer for number 1. Now number 2, we have a repeating decimal here. Now in this case, I would change this fraction to a decimal and compare. So we would take 9 into 4, and we'll put our decimal here. Now put 3 zeros here. You could put 2 or you could put 1. Doesn't matter. 9 goes into 4 0 times. 9 goes into 40 4 times. 4 times 9 is 36. 40 minus 36 is 4. Now if you only added 1 0 here, you have to add another 0 and then bring it down. 9 goes into 40 4 times. 4 times 9 is 36. 40 minus 36 is 4. We're going to keep repeating this, so this will end up being 0.4 repeating. So these two are equal. Now with number 3, change this decimal to a fraction and do cross multiplication again. 5 times 100, 7 times 72. We have 500 and 504. 504 is greater than 500. So this will point towards the 5 sevens. Do problems 4, 5, and 6. Now we have a negative fraction and a positive decimal. Whenever you compare negative and positive, positive is always greater than negative. So the 0.72 is greater than the negative 7/9. Now we come here to number 5. We have negative 5 sevens and a negative 0.72. So what we're going to do here, we're going to take 7 into 5, then go at least 3 decimal places. 7 goes into 5 0 times. 7 goes into 50 7 times. 7 times 7 is 49. 50 minus 49 is 1. Bring down your 0. 7 goes into 10 once. 1 times 7 is 7. And we could stop here. This would be a negative 0.71 compared to negative 0.72. We know that when we're dealing with two negative numbers, whichever one is closest to 0 is the greatest. So this negative 5 sevenths is greater than the negative 0.72. Now we come here to number 6. It says write the numbers in order from smallest to greatest. Now we will have to divide this out here, these fractions, and at least go to about 4 decimal places if necessary. Because we already have one number that's to 3 decimal places. 3 goes into 1 0 times. 3 goes into 10 3 times. 3 times 3 is 9. Bring down your 1, bring down your 0. 3 goes into 10 3 times. And what you will see here is that we have a pattern. So really, this is like 0.3 repeating. Now we want to do 3/8. So we'll do 8 into 3 point, just go to 4 places. 8 goes into 3 0 times. 8 goes into 30 3 times. 3 times 8 is 24. 30 minus 24 is 6. Bring down your 0. 8 goes into 60 7 times. 7 times 8 is 56. 60 minus 56 is 4. Bring down your 0. 8 goes into 45 times. 5 times 8 is 40. We had no remainder. So it'd be 0.375. Now we could go here. It says from the smallest to the largest. So 0.302 is the smallest. The next is 1/3. And finally, 3/8 is the largest. Okay, we're done with this section. Now we scroll down here to section C. We have order of operations with decimals and fractions. Okay, number 1, we have our parentheses. Number 2, we have our exponents. And we know step 3 is multiply or divide, whichever one comes first from left to right. And then finally add or subtract, whichever one comes first from left to right. Now it says example, simplify. If a problem contains both fractions and decimals, rewrite the problem using all decimals or all fractions. What this basically is telling you to do is, once you switch over to one method, stick with it. Don't keep flip-flopping. So let's see here. This has a decimal and no fractions. So let's first do this. We have 897.8 divided by 100. This 100 is a power of 10. So what we will have to do is move this decimal 2 places to the left. And we'll have 8.978. And then now it'll be times 10. So we have 8.978 times 10. This is a power of 10, but this is multiplication. So we'll move this decimal 1 place to the right. So it'll be 89.78. Now we come here to number 2. We do what's inside the parentheses first. Now what we should do is change these mixed numbers to improper fractions. So this would give us 9/5 minus 16/5. So we had negative 8.69. 9/5 minus 16/5 will give us a negative 7/5. Now we have the choice of changing this to all decimals and multiplying, or changing this to a fraction times a fraction. Now, in my own personal opinion, I would change this to a decimal. I think this would be a lot easier. So let's take 5 into 7.0. 5 goes into 7 one time. 7 minus 5 is 2. You bring down your 0. 5 goes into 20 4 times. So 4 times 5 is 20. So remember, this should be negative, so it'd be a negative 1.4. So we have a negative 8.69 times a negative 1.4. So now we can multiply these. We know a negative times a negative is positive. So we could take 869 times 14. Remember, we'll get rid of the decimals and add them in later. 4 times 9 is 36. Carry our 3. 4 times 6 is 24. Plus 3 is 27. 4 times 8 is 32. Plus 2 is 34. We add our 0 here. 1 times 9 is 9. 1 times 6 is 6. And 1 times 8 is 8. When we add these together, 6 and 0 is 6. 9 and 7 is 16. Carry a 1. 6 and 4 is 10. Plus 1 is 11. Carry a 1. 8 plus 3 is 11. Plus 1 is 12. Now, we count how many digits we have behind the decimal. From the original problem, we have 1, 2, 3. So we go 1, 2, 3. So it'll be 12.166. And that will be our final answer.